Hey, here we go, everybody. Assignment 3D. Um, what 3D is all about is introducing us to standard deviation. Um, what a standard deviation is this. I'll just kind of give a brief explanation of what a standard deviation is if I have these numbers that are in a list, have all these numbers, and we say this is the average. Okay, all of these numbers are going to have some sort of difference from the average. All right, some of those differences will be small. Let's say that's 1 under, that's 3 under, that's, oops, excuse me, that's where. Let's say that is, 7 under, again, 7 under, or something like that. And let's say that there's numbers over. Let's say that this is right on the money. It's exactly the average. And then this one is, let's say that this is, 2 over, and this is 9 over, or something like that. Okay, and then so what you do is you take all of these differences, in essence. Take all of these differences. All right, think of them as kind of like absolute values. And we add them all up and divide by the number of them. So this very specifically would be what? 22 divided by 6. And so that will get you this number that is called a standard deviation. It'll go by a couple different symbols. These are the standard deviations. Okay, standard deviations. And what a standard deviation generally tells you is typically how far a list is spread apart from each other. Are the numbers really like close to each other? Like, it's like 1, 1, 2, 3, 3. Like, are the numbers like pretty close to each other, or are the numbers really spread apart? Like, this is 1, this is 20, this is, 100, this is 200, and this is 300, or something like that. Are the numbers really far spread apart from each other? That's kind of what a standard deviation generally kind of talks about. That's like real quick and dirty. That's what a standard deviation is it kind of tells you the spread of data in comparison to itself. Okay, and we are going to be learning a few different things along with that, variance, and this other thing called the coefficient of variation. Before we get there, the easiest way to do this is you have to kind of get the formulas for this. Start with the variance. The variance, S squared. S squared is equal to the sum of x minus x bar squared divided by n minus 1. Okay, s minus x bar squared divided by n minus 1. Okay, that's the hardest one, and I'll talk about all those pieces here in just a second. The second one, we are looking for the standard deviation. But if you look at the variance, s squared, how do you get an s from an s squared? Well, you square root it, of course. So whatever that answer is in question A, you just square root it, and that is going to be your standard deviation. And the last but not least is the coefficient of variation, and that's going to be s divided by x bar times 100. And I'll kind of hint you in on the meaning behind the coefficient of variation here in just a second. Okay, so those are your big formulas. You probably want to write those down somewhere, especially since we're going to be taking a test. You need to know these formulas. So write them on, like, start creating a formula sheet or something like that of things that you need to remember. Because if you just bank on your memory to remember this stuff, it's probably not going to work out too well. So write it down somewhere so you have quick and easy access to it. Okay, looking at this formula right here, we know a lot of the stuff, but let's just kind of review what some of the stuff is. And then there's also other things that aren't as obvious that you probably haven't seen before. All right. Okay, so let's start it symbol by symbol. This means that we're going to sum something. So calculator speak, it's the sum, it's where we add things up. All right, we know what that symbol is. X. Okay, X is not a number, X is the list. X is the list. So X is 17, 19, 20, 27, 27. It is the list itself. And so we're going to be putting that into our calculator in that stat screen as list 1 here eventually. N, let's skip over X bar here real quick. N is, we used that a couple lessons ago. It is the number of elements, number of things. So very specifically, that would be 5, the number of numbers in the list. All right, so this would be very specific, 5 in this problem. What is X? Excuse me, X bar. This is called X bar. And this is new. X bar. X bar is, what a bar does, it is the average. It's the mean. It is the average of X. Like, so you might see it in other things like Y bar. And so that's going to be the average of Y. And so the bar just usually indicates that it's an average. All right, so what are these things in this particular problem? Okay, so we already described that N is the number of numbers. In that case, it's 5. I'm going to speak calculator, and I'm going to put this X into list 1. All right, and then the X bar is going to be the average of that list. So what I'm going to do is I'm going to go to my main calculator, I'm going to add up those numbers and divide by the number of numbers, 5. And so that comes out to be very specifically the number 22. So I just found the average. I added them up and divided by the number of numbers. Okay, so on to problem number 1. All right, so we can pretty much type this in straight up, like this numerator. Don't put it on the denominator just yet, but we can pretty much type this straight up as long as we use parentheses in the numerator. So that is the sum, open, X, which is list 1, minus X bar, which is 22, closed, squared, closed. Just following that formula. Sum, open, list 1, minus 22, closed, squared, closed. So that numerator comes out to be 88. The denominator is n minus 1. So this variance is 22. So S, this is part B. The standard deviation, S, is the square root of S squared. That's just mathematical logic. So that means this is going to be the square root of 22, or square root calculator speak. That's going to be the square root of the answer that I have in my calculator right now. So square root of the answer. So that's S. Coefficient of variation is going to be S divided by X bar times 100. So that's going to be 4.6904 divided by X bar, which I believe was 22, times 100. X bar was 22, yeah. So S divided by X bar times 100. But actually, I'm not going to start and retype that again, because the moment that I start typing 4.690 is the moment that my answer gets less accurate. So what I'm going to do is I'm going to take the answer that is in my calculator, I'm going to divide that by 22 and then multiply by 100. All right, so I take that answer, I divide by 22, and then multiply by 100. What a coefficient of variation is how big is your standard deviation in comparison to the average itself. So the coefficient of variation is actually the good measure of how far, quote unquote, numbers are apart from each other. So how far numbers apart from each other, because it takes a number that it has in common with itself. Like, so for instance, if I'm saying, like, what is the distance between cars while driving down the road? Okay. A typical number is, like 30 feet or something. All right. But if I compare that with what is the average distance between planets, those numbers are way farther apart. But, like, how close is the moon to the Earth? Well, it's really, really, really close, but in comparison to the distance of cars from each other driving down the road, it's super far. So what you got to do is you got to kind of somehow put it in context of the scenario, and that's what a coefficient of variation does. So the bigger the coefficient of variation is, it's the general size of the standard deviation itself. So the bigger this is, the numbers are really far apart from each other. The smaller this is, the numbers are really, really close from the average. Anyways, I digress. Again, the easiest thing how to get these problems done is you have to know the formula. So S squared is equal to the sum, double open, X minus X bar, close squared closed, by N minus 1. S is just the square root of S squared. And then the coefficient of variation is S divided by X bar times 100. All right, so you have to know the formulas, and then it's also obvious good policy to find the important pieces before you get going. So I'm going to make X my list 1. N I see is 5. And then X bar. Okay, enter those numbers in, go back to my calculator, I add those up, divide by the number of numbers, so I add up list 1, divide by the number of numbers, which is 5, and I get an average number of 49. So I can pretty much plug and chug into this equation right here. So the numerator is the sum, open, X, which is list 1, minus X bar, which is 49, closed, squared, closed, divide by N minus 1. S is just the square root of that. And then the coefficient, which is S, which is my answer. Okay, so my answer, I'm not actually typing that in, answer divided by X bar times 100. So these numbers are really far apart from each other in comparison to the average. So you can relate this answer to the answer of number 1, even though they have nothing to do with each other. Wow, these numbers are really far apart from each other.